In the situation of the previous exercise, assume that diagonal AC bisects diagonal BD. We want to prove that this quadrilateral is a rectangle. So, remember in the previous problem, we assumed that angle A was congruent to angle C, and then from that, we're able to deduce that ABCD is cyclic, right? So, let's go ahead and start this proof. So from the previous one, we know that the measure of angle A was equal to 90, which was equal to the measure of angle C, which implied that ABCD was cyclic, right? And of course, now we're assuming that AC bisects BD, right? So that means BP is going to be congruent to PD, where P is the point of intersection of these diagonals. But we're going to come to that a little bit later. Also, by the inscribed angle theorem, because since ABCD is cyclic, that means A, B, C, and D are inscribed angles, right? So by the inscribed angle theorem, we know the measure of angle A is equal to half the measure of arc BCD. And then, of course, we know A is 90, so that means 90 is equal to 1/2 the measure of arc BCD. If we multiply both sides of this equation by 2, we get 180 is equal to the measure of arc BCD. And then, of course, this implies that arc BCD is a semicircle. And if BCD is a semicircle, that means BD must be a diameter. All right, for the circle containing A, B, C, and D. Right? Of course, now it's going to come into play that AC bisects BD, right? Now we're going to use the fact that AC bisects BD. So this implies that BP is congruent to PD. And if I have that BD is the diameter for the circle containing A, B, C, and D, and that BP is congruent to PD, right? This means that P is the center of this circle, right? Since BP is congruent to PD and BD is a diameter, right? That means that P must be the center, right? So if P is the center, this means that this implies that AC is a diameter for this circle, right? All right. So this implies that ADC, right? ADC, this arc is a semicircle for this circle, right? And then, if that's a semicircle, this implies that the measure of arc ADC is equal to 180. Now, by the inscribed angle theorem, I know that the measure of angle B is equal to half, right? If I go up here, half of ADC, which of course is half of 180, which is 90. Now, since ABCD is cyclic, this implies that I already know that measure of angle A plus measure of angle C is 180 because both of them are 90, but this also means that B and D, the measure of angle B plus the measure of angle D, is equal to 180. Since I know that B is 90, this implies that 90 plus the measure of angle D is equal to 180, which of course implies that the measure of angle D is 90. So we have the measure of angle A is equal to the measure of angle B, which is equal to the measure of angle C, which is equal to the measure of angle D, and all of them equal 90. So now I know the measure of angle A plus the measure of angle D is 180. The measure of angle A plus the measure of angle D is equal to 180, right? So the sum of these two angles is 180, implies that AB is parallel to DC. AB is parallel to DC, or CD, and I know that the measure of angle A plus the measure of angle B is 180. And that implies, so A plus B is 180, so that means that AD is parallel to BC. AD is parallel to BC. So I have AB is parallel to CD, and AD is parallel to BC, which implies that ABCD is a parallelogram. And I know that it's a parallelogram with the measure of angle A equal the measure of angle B equals the measure of angle C equals the measure of angle D equals 90. So this not only implies that ABCD is a parallelogram, it implies that ABCD is a rectangle. And that is my proof.